All right. All right. Good evening. Students, can you confirm whether I'm audible? Okay. All right. Thank you. Since some of you are still joining, and some of you might have in the YouTube live as well, because I'm streaming this today on YouTube as well. I'll wait for another 2 minutes and we'll start. And get ready yourself with the paper, because we'll be straight away going to the discussion today, right? And if there's anyone who didn't get the paper through groups, right? If there's anyone who didn't get the paper through groups, you can drop me a message through this number. Then I can send you the paper. 071 618 8597. Right? So if there's anyone who didn't get the paper through groups, please drop a message to this that you didn't get the paper, then you will get it. All right. Okay, it seems all of you have got the paper by now, right? Okay. Right. So we are in paper 2, part 1 of paper 2. And for the usual students, regular students, you got this paper on Thursday, right? You got this on Thursday. So I hope all of you have tried this out. And today we'll be straight away shifting to the discussion. And for the new students who joined today, you might have got the paper today, right? Then sometimes you might not get the time to try it out, right? So next week onwards, you will also get the paper 2 days before the discussion, and you can try it out before the discussion and join the class, right? Okay, let's start. First one. The SI unit of coefficient of viscosity. SI unit of coefficient of viscosity. So repeating again, if there's anyone who didn't get the paper yet, drop a message to this number, then you can get it, right? The SI unit of coefficient of viscosity is, for viscosity we have 3 equations, right? Newton's equation, Stokes equation, or Poisson's equation. You can use any of the equation and get it done. Question 1. You got here? Question 1. Coefficient of viscosity. So I'll be using Stokes equation. F equals 6phi eta RV. Stokes equation. F equals 6phi eta RV. We need units of eta, right? Then units of F. 6phi is a coefficient, so that is unitless, right? That's a number, unitless. We need units of eta and units of R times units of V, right? Units of force is newtons. We need units of eta units of radius. Radius is meters, that's a length in meters. And v is a velocity that is in ms minus 1. Velocity that is in ms minus 1. Simplify this. So units of eta will be ns m minus 2. ns m minus 2. ns m minus 2 කියන්නේ answer 3. For 1, answer 3. I'll be mentioning the answers here. Yeah. For 1, answer 3. Right. For 1, answer 3. Second one. In second one, the word quark is a typing mistake. There's no word quark. Word quark is a typing mistake. Angular displacement theta is given by theta equals k alpha t squared. If alpha is angular acceleration and t is time, the dimensions of k is right. Second one. Theta equals k alpha t squared. Theta equals k alpha t squared. Right. So we know theta is an angle. Angles are dimensionless. Right. Theta is an angle. Angles are dimensionless. And k is given as k is asked. Okay. Then dimensions of theta will be dimensions of k times dimensions of alpha times dimensions of t squared. Right. But angles are dimensionless. Theta is an angle. Angular displacement is an angle. Angles are dimensionless. Right. Angles are dimensionless, and we will consider dimensionless quantities as 1 for our calculations. We need k and alpha. Alpha angular acceleration. Dimension of angular acceleration is t minus 2. That you need to know. Right. So I'll be substituting at once. There is t minus 2 times t is time t squared. T minus 2 to t squared cancels. K equals 1. 1 means dimensionless. K equals 1. 1 means dimensionless. Dimensionless, which means no dimensions. For 2, answer 5. No dimensions. Right. Take down if you need anything to be taken down. Then 3. Centripetal acceleration of a particle which is moving in a circular path with uniform angular velocity of omega is f. The graph between omega and f is correctly represented by, right, graph plotting. Take the equation first. Centripetal acceleration, no? Centripetal acceleration, that is given as f here. So we know centripetal acceleration can be written as r omega squared. Using omega, centripetal acceleration is r omega squared. Right? Now omega is in y. So subject omega first, which means omega squared is f over r. So omega can be written as root f over r. That is root f over r. For my clarity, I will separate this as 1 over root r times root f. No change, no? 1 over root r times root f. No change. Right? Okay, now we can identify these terms. You can identify these terms. Omega is at y. Omega is y. And f is x. F is x, which means this is root x. And whatever the coefficient that is as a product with x is gradient. So the shape is y equals m root x. Y equals m root x. That is a standard shape. Omega with f. y equals m root x, standard shape is this. Answer 3. For 3, answer 3. And if you are not there for the graph plotting class, graph plotting session, that video is available on YouTube. So you can go there and watch it. And there I have discussed all the things you need to know about graph plotting in physics. Right? So you can watch it and take this idea. If there's anyone who didn't know how to plot graphs yet. Next. Question 4. Specifications. A washing machine is operated with a motor of 320 watts and the rotating disc of it has moment of inertia of 5 kg m squared. Give me a second. I haven't plugged the route. Give me a second. Okay. Right. We are in question 4, right? Specifications. A washing machine is operated with a motor of 320 watts and the rotating disc of it has a moment of inertia of 5 kg m squared. Starting from rest, how long will it take to acquire a frequency of 240 rpm under the above power? Right. Okay. If power is given, first I can start with this. So you might know and you should know the equation of power or the relationship with power and velocity in linear motion. Right. That is P equals Fe. No? P equals Fe in linear motion. In rotational motion also we have the same equation as P equals torque omega. As P equals torque omega. Now these are rotational motion. Rotational. These are rotational motion. So therefore I'm going to use this equation. For that I need omega. Right? First I need omega. So my first target is determining omega. RPM is given. right? Since RPM is given, we can easily determine omega like this. We know omega equals 25 RPM over 60, right? So which means 25 RPM is 240 over 60. This is 60 times 4, which means omega equals 85. Omega equals 85, right? Omega is known. Now, if power and omega is known, torque can be determined, right? Now, P equals torque omega. P is 320 and torque, that is what I need, omega is 85, right? This is 8 times 40, ne? 40, which means torque equals 40 over 5, right? Now, to get alpha, since moment of inertia is given, we can use torque equals I alpha, right? Torque equals I alpha. See, we can use torque equals I alpha now. Torque equals I alpha. Torque is 40 over 5. I is 5 alpha. 5 times 8, ne? So alpha is 8 over 5. Alpha is 8 over 5. Now, to get time, I'm going to apply a rotational motion equation, right? See, then finally, I can use omega 2 equals omega 1 plus alpha t. Omega 2 is this omega, yeah, 85. 85. Omega 1 is 0. Starting from rest, it says, and alpha is 8 over 5 t. Right? Simplify this. 85 equals 8 over 5 t. Right? 8 to 8 cancels. T equals 5 squared. T equals 5 squared. And in the question, it says 5 squared equals 10. Right? So, which means final answer 10 seconds. 10 seconds. For 4, answer 5. For 4, answer 5. Right. Take it down quickly. Right. 5. Right. The image of an object which is 5 centimeters away from a convex lens is, it should be virtual, not virtuous. Right. That's a typing mistake again. It should be convex lens is virtual. Virtual. Right. An image which is real and equal in size to the earlier image is formed when the object is moved another 5 centimeters away from the lens. The focal length of the lens is. Right. That's a tricky question. Listen, that's a tricky question. First image is virtual. First image is virtual and it is 5 centimeters away. When another 5 centimeters is moved, right? Then a real same size image is formed. Then you have to know this. Only virtual image in a convex lens is when the object is kept between C and F, optical center and focal point, right? If that is at focal point, if the object is at focal point, the image is formed at infinity, right? And now about the size, something is given. Equal size, equal size. And for the virtual image between C and F, that virtual image is enlarged. And if the object is at F, the image is theoretically formed at infinity, and that image is exactly same in size for the object, right? So you should know these ray diagrams. See, if the object is kept at F, if the object is kept at F, this is what happens. This is what happens. This image is formed at infinity. This image is formed at infinity. This image is formed at infinity. And this is equal in size, right? And the next scenario, that's a real image equal in size to the earlier image, right? Equal in size to the earlier image, which means now real images are starting to form beyond F. It can be either between F and 2F or at 2F or beyond 2F. There are three cases, right? F and 2F or at 2F or beyond 2F, right? But if the sizes are equal, we can directly argue it as on 2F. Because on 2F, this is what is formed. Now, from your knowledge on convex lenses, you have to build these arguments F and 2F. F and 2F. Now, if the image is at 2F, sorry, object is at 2F, this is what happens. This is what happens. The image is real, this is real, and that is exactly at 2F. So sizes are same. Sizes are same. And this size is same as the size of object. Here also the same thing. So therefore, if the sizes are same, and if one image is virtual, and if one is this is virtual, this we can't see because this is at infinity. That's virtual, that is at infinity, right? Sizes are equal, and one is virtual and one is real. So which means these two scenarios are very much straightforward now. Then this has to be 2F. That is the point. Then this has to be 2F. Then if there is 5 centimeters away, and then again it takes another 5 centimeters. No. So which means, according to the case, this has to be 10 centimeters, right? Which means 2F equals 10, F equals 5. So F equals 5 centimeters. Focal length of the lens is 5 centimeters. For 5, answer 1. For 5, answer 1. Use these arguments accordingly. Now, since this is MCQ, you won't have a time. You don't need to actually. You don't need to spend a time to ray diagrams like this, right? I have drawn these ray diagrams for your understanding. Otherwise, now just by going through the question, you should be able to imagine these two scenarios and get it for this kind of a MCQ, right? Without these two ray diagrams. Otherwise, these two are the relevant two diagrams for these two cases, right? 6. The distance between the eye lens and the retina of a person is 2.6 centimeters. Eye lens and retina. This is the eyeball, and this is called the eye lens. And retina is the point where image of the eye is formed. Image of the object is formed inside the eye, right? 2.6 centimeters. Retina and the eye lens, which means this. This is also called diameter of eyeball. If his near point is located 28.6 centimeters away from eye lens, the minimum focal length of eye lens is, right? Now, first draw the ray diagram here, the relevant ray diagram. Now, from this near point, the rays are coming into retina like this, and the final image is formed at retina. Image is here, and the object is here. From here, rays are coming, and this length is given as 28.6 centimeters, right? Now we need to use Lenz's formula to do the calculation. Use Lenz's formula. So you know we have a sign convention in optics when using Lenz's formula. Sign convention is any direction which measures along the same direction of light is minus, and opposite direction to direction of light is plus, right? So with that, apply 1 OV equals 1 OV minus 1 OU equals 1 OF Lenz's formula. Lenz's formula 1 OV. Now apply your sign convention. Apply your sign convention here. Now V is at minus side. V is minus. This is V. V is minus. U is plus. Plus and minus means still there is minus. And F, I lens is a convex lens. I lens is a convex lens. So therefore, this is also minus. That is also minus. So we can multiply the entire equation with minus. Then it comes to 1 over V plus 1 over U equals 1 over F. 1 over V is 1 over 2.6 plus 1 over U is 28.6. Right? We need F. 1 over F. Simplify this. This is 2.6 times 28.6 over this is 28.6 plus 2.6. This is 1 over F. Simplify this. This is 31.2 and this is 2.6 times 28.6. A small simplification is there. Simplify it. That is my simplification is correct, right? The 2.38. 2.38. Do the simplification and tell me. 2.6 times 28.6 over this is 31.2 and 30. Yeah, 31.2. 2.38. 2.38. Do the simplification and check it. 2.38 centimeters. 2.38 is not given. 2.4 is given. Rounded answer is given. So which means it is 2.4 centimeters. 2.4 given answer 4. For 6 answer 4. The rounded answer is given. If you simplify this, you will get 2.38. And in the answer sheet, 2.4 is given. This is the 13th week before the exam, right? This is the 13th week before the exam, and now today we are on Saturday. So next week is going to be the 12th week before the exam, like 12th week. 12 weeks means that is just nothing. 12 weeks, exactly 3 months, right? Okay, 7. One end of a resonance pipe is open and the other end is open or closed, right? 7. One end is open or other end is open or closed, which means these two are scenarios. One end of the resonance pipe is open and the other end is open or closed. Yeah. Then one end is open or other end can be open or closed in these two. Ne? Okay. One end is open or the other end can be open or closed. Right? So that is about two scenarios. One end is closed. One end is closed. Sorry, one end is open. One end is open and the other end is open or closed. Yes. Then one end is open. If the other end is also open, that is both end open. If one end is open, if the other end is closed, that is one end closed. These two are the two pipes. Right? And the resonant frequency of the new air column is 125 hertz. Which one would not be one of the natural frequencies of it? Right? So you know, in this scenario, the frequencies go as starting from f naught, it go as 2f naught, 3f naught, 4f naught. Likewise, for any multiplier of f naught, there are resonance frequencies for any multiplier of f naught, right? And that is same for both end closed, both end open tubes or strings, right? Strings or wires. And only deviating scenario, the different scenario in these wave patterns are with one end closed tube. In one end closed tube, resonance frequencies are only for the odd numbers of f naught. So it goes like this. It goes like f naught, 3f naught, 5f naught, 7f naught, and so on. Only for odd numbers, right? Now what it says is 125 is a natural frequency, no? Then if these given frequencies are multipliers of 125, that might be a resonant frequency. If it's not a multiplier of 125, that is not a resonance frequency, right? So I can clearly see 900 is not a multiplier of 125. 250 is a multiplier of 125. 375 is a multiplier, 3f naught. 500, 4f naught. 625 and 5f naught. 900 is not a multiplier. So it cannot be a possible resonance. For 7, answer 5. That's a tricky question. That's a tricky question now. If you get this properly and if you know this from your knowledge, that is very much easier. Question 8. Question 8. If there are any clarifications needed, so you can put them to the chat box, right? So I can check it. 8. Speeds of air molecules are 0 kilometers per second, 3 kilometers per second, 5, 5, and 6. The root mean square speed of these 5 molecules is, okay, root mean square speed, C squared bar square root, right? C squared bar, this is called root mean square speed. Root mean square speed is coming like this. You have to know the equation. Now this is a known equation that I'm applying directly, right? Root mean square speeds, right? Square speeds take the square values of these speeds. And mean means the average. This means 0 squared plus 3 squared plus 5 squared plus 5 squared plus 6 squared. Mean of square values of speeds. Root mean square, right? Mean square speed. If you need the root, then you can consider the root, right? Square speeds. And if you need mean, divide it with 5, mean value. Divide with the number of molecules you have, 5 molecules, right? And root means square speed. Simplify this. Root 9, 25, 25, 36, or 5. Root 50, 86, 86 and 9 kilogene 94, 95, 95, 95 over 5. It is divisible. Root 19. 95 over 5 again, root 19, answer 3. For 8, answer 3. 9. The temperature coefficient of resistance of a metal by which a wire has been made is 1.25 times 10 to the power minus 3 per Kelvin. The resistance of it is 1 ohm at 300 kelvins. At which temperature the resistance would be 2 ohms. Right. The equation is very straightforward because we have only one equation. We have only one equation for the variation of resistance with temperature. We have only one equation for the variation of resistance with temperature. R theta equals R naught 1 plus alpha theta. Right? So apply that equation. 9. Apply that equation. R theta equals R naught 1 plus alpha theta. Right? R naught is resistance at 0 degrees Celsius. That is a constant. Therefore, R theta can be written as R theta proportional to 1 plus alpha theta. Right? So I'm going to apply this 2 times. I'm going to apply this twice. Right? For first scenario, 1 ohm, 1. Then 1 is proportional to 1 plus alpha is 1.25 10 to the power minus 3. 1.25 10 to the power minus 3. Theta is 300. 300. Right? And next scenario, 2 proportional to 1 plus 1.25 10 to the power minus 3. We need the temperature, let's say theta. Theta. Divide these two equations. Divide the equations. 1 over 2 equals from the other side 1 plus 1.25 from here 10 to the power 2 to 10 to the power minus 3 cancels, 10 to the power minus 1 remains. 1.25 times 3 can 3.75, which means 0.375. 0.375 over 1 plus 1.25 times 10 to the power minus 3 theta. Simplify this. This is 1 plus 1.25 10 to the power minus 3 theta equals, this will be 1.375. 2 times 1.375 again 1.75. 1.75. Sorry, 2.75. 2.75. This is 1.375. Then cross multiplication with 2. 1.375 times 2 means 2.75. 2.75. 2.75. Okay, then 1.25 10 to the power minus 3 theta equals 2.75 minus 1 can 1.75. Okay, this cancels with 0.25. This is 0.25 times 5, and this is 0.25 times 7, right? Which means theta equals 7 over 5, and when this goes to the other side, 10 to the power 3, right? 7 over 5 again 1.4. 1.4 times 10 to the power 3. 1.4 times 10 to the power 3. Again 1400 kelvins. 1400. Answer 2. For 9, answer 2. Okay, question 10. The frequency of oscillation of a string which is tight at both ends is 1000 Hertz. The frequency of oscillation of it when the tension is increased by 21%. Right. When percentages are given, listen, when percentages are given, it is easy to us to consider one instance as 100. Then if there is increase by 21%, we can write the second instance as 121. Right. So if it says it decreased by, let's say, 10%, then 90. So likewise, when percentages are given. As a habit, consider one state as 100. Then that will be easy. Okay. The frequency of oscillation of a string which is tied at both ends is 1000. The frequency of oscillation when its tension is increased by, right. So we know velocity of uh, transverse wave in a wire is root T of m. V equals root T of m, right? And V is F lambda. F lambda is root T of m. And m is not mass. M is mass per unit length. Oh, that is called linear density. This is not a mass. This is mass per unit length. Mass per unit length. That is also called linear density. This is constant for a given material, right? This is constant for a given substance. That is constant for a given material, right? And lambda is also same here. We are asked to determine when the tension changes. Yeah, then lambda is constant, m is constant. Then F is proportional to root T. This is the finalized equation I have. F is proportional to root T. Use this equation 2 times. Use this equation 2 times. For first scenario, 1000 is proportional to root. Initial scenario, I'll consider it as 100 T. And second scenario, let's say F is proportional to, if there is increase by 121 T. Divide these two. Very easy. Very easy. 1000 of F equals, this is root 100 T over 121 T. T to D cancels. T to D cancels. And we know 1000 over F equals root 100 is 10. Root 121 is 11. So these two cancels. Cross multiply. F equals 1100 hertz. 1100. Answer 2. For 10, answer 2. Right? Write it down. Any questions? So I didn't get ninth equation. Ninth equation. This is the relationship between temperature and resistance. R theta equals R naught 1 plus alpha theta. Right? R theta is resistance at a given temperature. R naught is resistance at 0 degrees Celsius. Alpha is called temperature coefficient of resistivity, or it is also called resistivity coefficient of temperature. Both are correct. Temperature coefficient of resistivity or resistivity coefficient of temperature. And theta is present temperature. Theta is present temperature. And in that question, it was given as at 300 resistance was given. And we are asked to determine the resistance when, temperature when the resistance is 2 ohms. When resistance is 2, then I assume that temperature as theta, and by dividing equations, we found theta. Right. Yeah, take it down. Any other questions? Okay, let's move on. Right. 11. Okay, the relationship between two variables x and y of a sound wave is represented by a sinusoidal graph as shown in the figure. If x is the distance towards the direction of energy transfer, what is represented by y out of followings? Right. For this, you have to have some kind of knowledge on waves and simple harmonic motion. Right, both will be used. Yeah, both are used. See. Okay. 11. Displacement of particle at the moment. Displacement with distance. If x is the distance towards direction of, okay, x is the distance, right? Now with distance, any simple harmonic motion is also a wave. See, any simple harmonic motion is also a wave. So this is one rotation, one swing of a simple harmonic motion, right? Now displacement is starting from center. This is called center, and these points are called amplitudes of a simple harmonic motion. This is called the center, and these two are called amplitudes. And displacement is always measured from center only in a simple harmonic motion. So displacement of a simple harmonic motion is 0 at the center, and when it goes to amplitude it increases, and again when it comes back it decreases, and to the other direction, opposite direction is opposite, right? It should be minus and increasing, and this is at the maximum and again coming back to 0. Then with distance, plus minus changes, right? Displacement again, it's a vector, so plus minus changes, and it is reaching maximum points and minimum points. Maximum and minimum means 0, right? So which means for that this graph is acceptable, because if that is at 0, if that is displacement, it should be 0, right? And then reaching the amplitude and coming back again, and after the center the direction changes, it is going to the negative side. So A is correct. A is a possible graph. A is a possible graph, right? Acceleration of the particle at the moment. Acceleration with distance, right? Acceleration is also same, because acceleration follows this. B. Acceleration is A equals minus omega squared x for a simple harmonic motion, no? So which means acceleration is according to minus x. Omega squared is a constant. So acceleration is according to minus x. X is displacement. Then what happens to displacement will be same as for acceleration. Now here I have already argued for displacement. So what is happening with displacement will be same as acceleration, right? Acceleration of the particle at the moment, that is also correct. B is also correct. So B is also correct. C. Pressure at the moment. Pressure. We can directly reject it because pressure is a scalar. Since pressure is a scalar, pressures don't have plus minus signs. That's a scalar, right? So that is wrong. Only A and B. Answer 2. For 11, answer 2. For 11, answer 2. 12. A boat travels at a uniform velocity of 10 ms minus 1. The resistive force against the motion of the boat is 400 newtons. The power of the engine of the boat. Very easy. Very easy. And this is actually the easiest question so far. So we know P equals Fe. In one of the previous questions also, I reminded the equation. P equals Fe. Right? So I reminded the equation P equals Fe. Power is, we need to determine power. And F is 400. V is 10. That is 4,000. 4,000 watts. 5. For 12, answer 5. 13. A ball on a smooth horizontal plane at a uniform a ball moving on a ball moving on a smooth horizontal plane at a uniform velocity collides against a vertical stationary ball and bounces back perpendicularly to the ball. If the collision is elastic, right? So you know elastic and inelastic collisions. Elastic means there is energy loss due to collision if the collision is elastic. If a collision is inelastic, which means there is an energy loss due to collision, right? Now this collision is elastic, which means no energy loss. No energy loss, right? Elastic, graph between speed of the ball and time t is speed and time, not velocity, speed. Speed is not a scalar, speed is not a vector, speed is a scalar, right? So at once, I can remove answers 4 and 5 because speed is a scalar. So that quantity cannot be plus and minus, right? It cannot have negatives and positives. That is a scalar quantity. So directly I have removed 4 and 5, right? Now this is the scenario. This is a vertical wall. This is a vertical wall, and this ball travels with a uniform velocity and collides with this, and it bounces back. No, it bounces back, and when it bounces back also, the velocity will be same as u. The reason is the collision is elastic, right? So speed is same as u. Speed graph is asked, right? There is no change in the speed, no change. So answer is 3. For 13, answer 3. For 13, answer 3. Collision is elastic. These are the points. Collision is elastic. So there is no energy loss. So therefore, velocity of the ball before the collision equals velocity of the ball after the collision, right? If velocity is asked, it should be in positive and negative sides because direction changes, but speed is asked. So there is no scalar, no vector properties for speed. That's a scalar. So that should be same. Answer 3. 3. 14. Consider Earth as a spherical object with radius r, at which value for h the gravitational acceleration is half of the gravitational acceleration at the surface of Earth. Right. So we know that last week also I discussed a gravitational field essay question in last class. Yeah, we discussed the gravitational field essay question in last class, and there also I discussed the same question, same equation. Gravitational field intensity can be written as G dash equals Gm of x squared. G dash equals Gm of x squared. X is the distance from center of the mass to considered point. Right? Now at Earth's surface, G dash is G. Right? So at Earth's surface, G dash is G. So G can be written as Gm over R squared. Right? And at this point, where it's distance away from the point, now the question is to the point where the gravitational acceleration is half. half, right? Then at the other point, it should be g over 2, gm over. This distance is, x is always the distance from center. This is measured from center. This is measured from center. So which means r plus h whole thing square. R plus h whole thing square. Divide these two. Divide these two. G over 2 and 2. G cancels. Right? Gm to Gm cancels. G to G cancels. Gm to Gm cancels. Then from here, R plus h squared over R squared. Now at once, I'm going to consider the square root of both sides at once. Square root. Then root 2 equals R plus h over R. Then root 2R equals R plus h. H equals, we can take R out, root 2 minus 1. H equals, R can be taken out, root 2 minus 1. 3, ne? 14, answer 3. An object of 2 kilograms is kept on a rough plane which is inclined 30 degrees to the horizontal as shown in the figure. The object is fixed to a point at the top of the plane by a light inextensible string parallel to plane. Right. Two kilograms, which means that is 20 newtons, and this is 30, right? So if that angle is 30, so we know this angle is also 30. Look at here. So we know if this is 30, this angle is also 30, right? Which means this is 20 cos 30, and this whole component is 20 sin 30, right? That whole component is 20 sin 30. Right, and let's say tension is T. Now, tendency of motion of this block, object is to downwards. So, friction will be upwards. There is a force diagram, right? Okay, first let's see what the friction force here is. Now, if we use F equals mu R, now I have discussed this scenario several times. If we use F equals mu R, we will get only the limiting friction. Na? Other frictions cannot be get. We will get the limiting friction. Then mu is given root 3 over 2. Root 3 over 2. And R is, R. This is R. R is this 20 cos 30. R is 20 cos 30. Which means F equals root 3 over 2. 20 cos 30 and root 3 over 2. Right? 2 times 2 is 4. This is 4 times 5. Root 3 times root 3 again 3. Which means this is 15 newtons. 15 newtons. Right. Now, let's check the force diagram here. Right. See, what is this value? 20 sin 30. 20 sin 30 again 20 times sin 30 is half. 10 newtons. Right. So, which means, look at here. Now, this is a good one. This is a good one. This force which is acting downwards is 10 newtons. And this is the limiting friction value. This is the limiting friction. This is actually the limiting friction. Once we apply F equals mu R, always you will get limiting friction only. Right? Otherwise, you don't get the frictions at intermediate points. Right? You will get the limiting friction. Now, limiting friction at this scenario is 15. But yet, the downward force is 10. Which means, this 10 will be counterbalanced by friction in the self-adjustment region. And now in this case, friction will also be adjusted to 10. Right? Because this tendency is 10, friction will be adjusted to 10 newtons. Self-adjustment. Self-adjustment. Now, to counterbalance this 10, friction is also 10 now, which means this 10 to friction 10 is balanced already. So, T is 0. T is 0. Right? So, therefore, T is 0. Right? On equilibrium එක ලියන්න පුළුවන් ඉතින් ලියලා බලන්න ඕනේ නැහැ නේද? Downwards we have 10, upwards T plus F. Right? So 10 equals T plus F is also 10 now, self-adjustment. T equals 0. So this is what I got at once. T equals 0. Answer 1. 15, answer 1. T equals 0. That's a tricky question. That's a tricky question from friction. The idea is friction itself is enough to balance this. මෙයා balance කරන්න friction එකට පුළුවන් නම් there is no point of stretching the string. So which means the string is not stretched. Right? Tension is 0. There's no weight on the string now. There's no weight on the string now. This total 10 newtons is counterbalanced by only by friction alone. Right? That's the idea. That's a tricky one, tricky question. Next. $16. Okay. Humidity. 16. Relative humidity of the atmosphere is 50% at 30 degrees Celsius. The temperature is increased instantly up to 35 degrees Celsius, and addition or removal of water vapor was not occurred. Right? So if there's no addition or removal, which means the pressure remains same. If saturated vapor pressure at 30 and 35 are P30 and P35 respectively, relative humidity of atmosphere at 35 is. Right? So in terms of pressures, we can write relative humidity as, in terms of pressures, we can write relative humidity as Y equals P over P naught times 100%. Y equals P over P naught times 100%. Right? P is partial pressure or pressure of actual water vapor available, and P naught is, you can't see the equation. Right? This is the pressure of actual water vapor available in the atmosphere, and P naught is saturated vapor pressure. Right? If there is no addition or removal, P remains same. Pressure remains same. Now we can use this equation for these two scenarios given. See? You can use this equation for these two scenarios given, like this. At 50 and, sorry, at 30 and 35. At 30, this is 50%. Right? 50 equals, this is at 30, yeah? At 30. 50 equals P over P30. P30 times 100. And we need Y, ne? Yeah, Y equals, P remains same, and at 35, saturated vapor pressure is P35 times 100. Now we have two equations. Divide these two equations. 50 over Y equals, from this side, P times 100 over P30, and here P35 over P times 100. P times 100 to P times 100 cancels. I need Y, right? I need Y. So Y equals 50 times P30 over P35. 50 times P30 over P35. 50 times P30 over P35 equal to 50 times P30 over P35. Answer 3. For 16, answer 3. So 16, answer 3. Seventeen. An electron of mass m is accelerated under potential difference of V. The de Broglie wavelength of it is lambda, to which value the de Broglie wavelength is equal when a proton of mass m is accelerated under the same potential difference. Right. So first thing, what is the equation of de Broglie wavelength? Very straightforward. We have only one equation, lambda equals h over mu. Equation of de Broglie wavelength. Lambda is de Broglie wavelength, h Planck's constant, m mass of the particle, u velocity. Right. Now, potential difference is given. Right. Since potential difference is given, to convert the velocity into potential difference, to convert this velocity into potential difference, what you can use is, you can use an electric field equation, an equation from electric fields. Right. A very popular equation, W equals Q delta V. W equals Q delta V. W represents work or kinetic energy. Now, in this case, we can expand that as kinetic energy. Half of mu squared equals Q delta V, which means subject U. U is 2Q delta V over M square root. Right? Now, I can rewrite de Broglie's equation as, lambda equals h over m. For u, I can write this 2q delta v over m. Now this root term to this m cancels root term, which means lambda equals h over root 2q m delta v. So likewise, first you have to create that equation. First create that equation. Right? Then see an electron of mass m and a proton. Yeah. So in terms of the charge, electron and proton is equal in terms of the charge. So therefore, charge is a constant for these two scenarios. 2 is a constant. H is Planck constant. That is anyway a constant. And it is projected under, accelerated under same potential difference. Potential difference is also constant, which means from this, only this part is needed. Lambda equals 1 over root 10. Right? Apply it twice. I'll use it here. See, lambda equals 1 over root 10. Apply this twice, like this. For first case, it is lambda, right? Lambda 1 over may electron negative, may proton negative. Root simple m. And for proton, let's say lambda dash 1 over root capital M. Divide these two. Lambda over lambda dash equals root capital M or simple m. Right? So when dividing, the reciprocals should be considered. Then I need alpha dash, lambda dash. Lambda dash is lambda times root simple m or capital M. Lambda times root simple m or capital M. 5. 17, answer 5. Right? $18. So if you got any questions, you can put them to the chat box. Due to which reason, out of the followings, a glass container is cracked when hot water is poured into it? Right. is cracked. Low heat conductivity of glass. Yeah, that's a possible reason, because if heat conductivity is good, what happens is the heat flows well. Heat flows through glass well, right? So therefore, no heat is going to be stored, deposited in glass, because if it is a good conductor, it conducts heat well without depositing it, without storing it, right? Low heat conductivity of glass is a possible answer. Let's see the others as well. Low specific heat capacity of glass. No. What determines by specific heat capacity is whether it can be heated or cooled faster or slower. The idea is like this. If specific heat capacity is comparatively higher, such objects takes much longer time to heat, to get heated. That's the idea, right? So therefore, with specific heat capacity, that is about the amount of heat it can be deposited in the material. It can be deposited in the material, right? So what it determines is not the cracking, that is the rate of temperature increase. That is the rate of temperature increase. Low volume expansivity of glass. Volume expansivity of glass is low, that is true, but that is not a reason to get cracked. High heat conductivity of glass. No, that is wrong. Glass is a low heat conductor, not a high heat conductor, right? High heat conductors are metals. Metal substances are high heat conductors. And high specific heat capacity of glass. No, in terms of specific heat capacity also, glass is a weak one, a low one. So answer is 1, low heat conductivity of glass. For 18, answer 1. That is just arguments. Arguments in the sense, now you have to know like what happens if conductivity is higher, what happens if specific heat capacity is higher. That is what I used, right? What specific heat capacity determines is the amount of heat it absorbs, right? When it comes to glass, glass is a low heat conductor with a lower specific heat capacity. So it can't bear much heat inside it. So therefore, since there is a low heat conductor, what happens is the heat is not conducting properly as well. So therefore, with that additional amount of excessive amount of heat which comes in, it will be cracked. Can we take volume expansivity? No. Reason is this: volume expansivity is not a reason to get cracked, right? Now, as an example, listen. As an example, say wood. Take wood, a piece of wood. Wood is a very weak material, very weak volume expansivity material. But even if we heat wood, it won't be cracked, right? Volume expansivity is not a reason to get cracked. That's the thing. 19. Then for 18, what was it? 3, ne? Oh, sorry, 1. For 18, 1. Yeah, I have mentioned. 19. The ice point of thermometer has been marked as -10. Right. Thermometers, very easier part, and actually the easiest part in thermal physics, right? Easiest part in thermal physics, right? Okay, this is incorrect thermometers. This is about incorrect thermometers. When it comes to incorrect thermometers, this is one of the easiest types of questions we have, right? So in one side, I'll mention the incorrect values, incorrect, and here I'll mention the correct values, incorrect and correct, right? Now, the ice point of thermometer has been marked as -10. -10, that is incorrect. So this is -10, and correct value has to be 0. 60 degrees Celsius is obtained when the temperature of a liquid in 50 degrees Celsius is measured, which means if 50 is measured, this rate 60, right? The reading obtained by this thermometer when the boiling point of water is measured. So we know boiling point is 100 and we need that respective temperature, right? To solve incorrect thermometers, just write down the ratio like this to this and this to this, Write down the ratio. Right? Theta minus minus 10. Theta minus minus 10 over 60 minus minus 10. And here 100 minus 0 over 50 minus 0. Just write the ratio. Theta plus 10 over 70, 100 over 50. 50 times 2. Theta plus 10 equals 140. Theta equals 130. 130. 4. For 19, answer 4. So when it comes to incorrect thermometers like this, there's nothing to think. If you know the equation, if you know the method, that's a very much gettable mark, and this is one of the easiest types of questions we have in thermal. Right? Very much gettable. Consider an object heated up to 80 degrees Celsius and kept in an environment of 30 degrees Celsius. The rate of temperature fall of initial temperature is 5 degrees Celsius per second. If the environmental temperature is reduced by 10, what's the rate of temperature fall of the initial temperature? Newton's law of cooling, right? Newton's law of cooling. Again, very straightforward because we have only one equation from Newton's law of cooling. We have only one equation, right? 20. The equation of Newton's law of cooling. That is Q over T equals EA theta minus theta R. Newton's law of cooling. Q over T is rate of heat loss, E coefficient of emissivity, and A area open to surroundings, theta temperature of the object, theta R room temperature or environmental temperature. Right? Now, since this is the same object, before that, temperature fall, rate of temperature fall is given, no? So we can expand this Q as ms theta. Ms theta over T equals EA theta minus theta R. This theta over T is called rate of temperature fall. Theta over T, rate of temperature fall. That is also called cooling rate. Theta over T. Since there is the same object, M is constant, S is constant, E is constant, A is constant. So what I need for proceedings is theta over T is proportional to theta minus theta R. Right? So I'm going to use this equation 2 times like this, considering these two scenarios. Right? Initially 5, then 5 proportional to theta again 80. Room temperature is 30. 80 minus 30. And second case, that is what we need, theta over T proportional to 80 minus 20. Right? If the environmental temperature is reduced by 10, what's it? Yes, 80 minus 20. Divide these two. Then 5 over theta over T equals 80 minus 30 and 50. 80 minus 20 is 60. Right? This is 5 times 10. These two cancels, which means theta over T equals 6. 20, answer 4. For 20, answer 4. Right? 21. A phenomenon which can be observed only in transverse waves. Very straightforward. Direct theories. When it comes to wave phenomena, right? When it comes to wave phenomena, we have 5 wave phenomena: reflection, refraction, diffraction, interference, and polarization. And when it comes to polarization, longitudinal waves cannot be polarized. There is the only different scenario here. And transverse waves do all these phenomena. Transverse waves do all the phenomena, and only longitudinal waves won't be polarized. So therefore, only for transverse waves, polarization. 21, answer 5. Very straightforward. Direct theories. 22. A violin play is broadcasted through a live radio program. The type of waves that transmit energy from the violin to listeners are right. A violin play is broadcasted through a radio program. Okay. Now, which means the origin of this wave is at the violin. So in the violin, we know we have wires, right? Wires. When wires are vibrated, in wires we have transverse waves only, right? In wires we have transverse waves, right? 22 ne? Right. So initially something like this ne? Initially this is at the violin. Initially these wires are in the violin like this, right? And it should be transferred to a mic. It should be transferred to a mic, and through the mic it will be transferred to the radio, then the radio, and from the radio it comes to our ear. And then only we will hear. It comes to our ear, then only we will hear, right? So which means in violin we have transverse waves, right? So in the violin here we have transverse, right? And this wave is propagating through air from violin to mic, propagating through air from violin to mic, right? Sound waves are longitudinal waves. Longitudinal. And from mic to radio, right? From mic and from system radio to from mic to radio broadcast, right? Broadcast again. There is a radio signal. Radio signals are electromagnetic. EM. Radio signals are electromagnetic, right? Radio. You know, radio signal is one of the signals we have in electromagnetic spectrum. So radio signals are electromagnetic. And from radio to our ear again, radio to listener, there is another sound wave through air medium. Sound waves are longitudinal, right? Which means transverse, longitudinal, electromagnetic, longitudinal. Transverse, longitudinal, electromagnetic, longitudinal. 2. For 22, answer 2. Right? 23. The corresponding displacement time graph for the given VD graph. VDST conversions. See, very easy. VDST conversions. See. Relationship between these two is gradient of ST is velocity. Right? Gradient of ST is velocity. Now, velocity is known. Knowing the velocity, I'm going to assume about, I'm going to guess the gradient of ST because now velocity is known, right? Then this part, at this part, velocity is negative. Velocity means not the gradient of velocity, yeah? Not the gradient of velocity time graph, that is about velocity. And I will get the gradient of this one. This velocity is negative. This velocity is negative. And that value decreases. Value decreases. So that is negatively decreasing. And this velocity is positive. This velocity is positive. And that value increases. Positively increasing. This velocity is positive. And the value is constant. Positive constant. And this velocity is positive. And the value decreases. Right? So that is the expected shape. Then positively decreasing. Positively decreasing kya lage aanne? Sorry, negatively decreasing. Negatively decreasing means this is the shape. Negatively decreasing shape. And then positively increasing. Positively increasing shape is this. Positively increasing. Then positive constant gradient. Positive constant gradients are this. Then positively decreasing kya hai? This. Now you have to know these shapes. Now repeating again. This is a graph question again. I have discussed these things in two places. One is in linear motion graph conversions. And recently I conduct a session on graph plotting. No, in graph plotting also I discussed about these gradient types, right? So you have to know these gradient types. So what's the answer? Answer 3. Answer 3. 3. 4, 23. 23, answer 3. $24. The diameter of moon is 20 times through the astronomical telescope as it is observed by the naked eye. If the focal length of objective piece is, it should be objective piece, is 1 meter, the focal length of the eyepiece is, right? Very straightforward again, very straightforward. In optics, optical instruments, we prove the magnification of astronomical telescope as angular magnification of astronomical telescope as FO over FE. Focal length of objective piece FO, focal length of objective piece over focal length of eyepiece, right? Then magnification is 20 times. FO is given 1 meter, 100 centimeters. OFE, see how easy this is? 5 times, which means FE equals 5 centimeters, right? 24, answer 3. Very easy. Very easy. So likewise, here and there, you will have some easy questions as well, right? So otherwise, in our papers, we don't have a pattern like first 10 questions are the easiest and last 10 questions are the most difficult ones, the hardest ones. No, there's no such pattern. There's no such pattern. So therefore, if you get stuck, if you feel like you are stuck at a question, you just need to move on to other questions and complete the first round, right? So that is how MCQ should be done. MCQ paper should be done. Otherwise, if you stay stuck at the same question for 5-10 minutes, then you will lose some easier questions which are along the way. So therefore, always now, if you didn't get a question, right, just feel free to move on to the first round, and then if the time remains again, you can come back and check. Yeah, within this month, most probably we'll be having that academic session as well, right? I told you that we are going to have an academic session on the techniques on writing exam papers, techniques, right? Yeah. So during month of August, we'll have it, right? We'll have it. I'll inform more details in the groups and channels. 25. Element X, which is radioactive, is converted into another stable element called Y. X is converted to Y. X is converted to Y. The half-life of the element is 8 days. The percentage of the number of X atoms converted into Y after 24 days. Right. 24 days means 3 half-lives. 3 half-lives. 24 days again. 3 half-lives are passed already. Right. So in radiation we have N equals NO over 2 to the power N. NO is the original number of nuclei, NO, original number of nuclei, and N is the present number or remaining number of nuclei. NO is original number of nuclei, and N is present number of nuclei. Present, or we can say remaining. Present or remaining number of nuclei. Right. Now, let's see what amount of X is remaining after 3 half-lives. Right. So N equals NO 2 to the power 3. Right. Then N over NO is 2 to the power 3 is 8. Right. 2 to the power 3 is 8. 1 over 8. Which means 1 over 8 is remaining. 1 over 8 is remaining. Which means 7 over 8 is converted. Alright? From X. Now 1 over 8 is remaining. May equation again remaining gone. So now 1 over 8 is remaining. Only 1 over 8 is remaining, which means 7 over 8 is already converted. 7 over 8 is already converted. And 7 over 8 times 100%. This is 87.5. 87.5. 25 answer 4. Okay, we are halfway through. Halfway through. Any clarifications, any questions up to this point? Now 25 MCQs are discussed. Right? Now 25 MCQs are discussed already. Right? Yeah. Tell me if there are any questions up to this point. Any clarifications needed or any questions? Anything to clarify? Anything? So what about it? Up to these 25 questions. Are you all clear up to here? So before moving on to the rest, are you all clear up to here? Or if you got any questions, feel free to ask anything and get it clarified. Right? So now 13th week is already gone. Right? Now you have just 12 weeks ahead of the exam. Right? 12 weeks. 12 weeks කියලා කියන්නේ it flies. It flies. ඕක තේරෙන්නවත් නැතුව යනවා හොඳ. නිකම්ම යනවා. තේරෙන්නවත් නැතුව යනවා. You have just 12 weeks now. So don't waste even a single minute nowadays when you work. Don't waste even a single minute when you work, because that counts. Even that minute counts. Right? A minute එකෙත් ඔයා පුළුවන් නම් MCQ එකක් හරි කරන්න. Don't waste even a single minute. Right? 12 weeks means that is not a time, not a time, not a considerable time. It flies. You are when you are balancing 3 subjects, right? I'm not just talking about physics, right? When you balance 3 subjects, when you are busy with your own work, right? The time flies, right? So when we are meeting next day, I'll say we have 11 weeks, right? So likewise, now in terms of days, now it is less than 100, 90, 98 or something, 98, 99 or something. Now it's less than 100. I think 99. Some of you might have tracking the days, right? I usually track number of weeks. Now this is the 13th week, and by tomorrow the 13th week is also over, and we have just 12 weeks. Sir, 25th question, can you explain it? 25th. 25th this one. In radiation, this is a crude equation. N equals N over 2 to the power n. This one, no? N equals NO over 2 to the power n. Right? And NO is original number of nuclei, and N is final number of nuclei, or we say remaining number of nuclei, or present number of nuclei. Right? Now, when X converts to Y, one half life is 8 days. Now, after 24 days means 3 half lives are passed. And simple N here is number of half lives. Simple N here is number of half lives. Number of half lives. Right? Then 3 half lives are passed, which means N equals N over 2 to the power 3. N over NO means this is the fraction between original number of nuclei and remaining final number of nuclei. That is 1 over 8. That is 1 over 8, which means only 1/8 from the original sample is remaining now. Only 1/8 of the sample is remaining now, which means 7 over 8 is already converted. 7 over 8 is already converted. Convert to Y. Convert in Y question it converts to Y. Okay. Is it all clear up to here? Can you at least put a thumbs up? Or else you can just type and it's clear. You can say it's clear by typing, or else just put a thumbs up. Okay. All right. Let's move on. 26. A ladder is in equilibrium on a vertical plane, which is perpendicular to the wall as shown in the figure below. One end of the ladder is on the rough horizontal ground, and the other end is resting against a smooth wall. Right? Like this. This is smooth. This is given. This vertical wall is smooth, and this is rough. Right? Okay. Now, the correct Fibonacci diagram for the forces acting on the ladder is which of the following state? No, that's a typing error. This question is the correct Fibonacci diagram for the forces acting on ladder is. That's it. Right? Okay, then here, from center of gravity, mg acts. From center of gravity, mg acts. And with this contact here, perpendicular reaction acts. Right? Let's say R1. And there is no friction here. Because that wall is smooth. And from here, with this contact, again, a perpendicular reaction acts. Right? And the moving tendency of this point is to left. Right? Moving tendency of this point is to left. So therefore, friction acts to the right. Like this. Friction acts to the right. Only 3 forces are marked now. Only 3 forces are marked, which means at this point, the resultant of friction and reaction is considered. Right? And you have to know the exact direction of that as well. Right? you can get the exact direction like this. Now, if I extend this mg to here, these two forces are intersected at this point. So we know if an object is in equilibrium under three non-parallel forces, all three forces should go through the same point, right? Which means all three forces will be intersected at the same point. So which means the resultant of these two should also go through the same point, like this. This is the resultant of both of them, right? Then the corresponding diagram is 4. For 26, answer 4. 27. Fibry diagrams, Fibry diagrams. 27. The figure shows the way that a beam of monochromatic light incidents on an optical system and emerges. The instrument combination which can be present in these optical systems are as follows: two convex lenses, one convex array. The correct combinations would be okay. Now, for your identification, these single arrowheads and double arrowheads are put, right? Using two convex lenses, no, it is doable. See? Now, if these two convex lenses are like this, single arrow and double arrow, right? See? If it is like this, it is doable. See? Then one convex lens and one concave lens. One convex lens and one concave lens. No. A is correct. A is correct. B, one convex lens and one concave. No. Because by concave lenses, now if that's a concave lens, if this kind of a ray comes, see, what happens is this. This is possible using concave lenses. This is possible using concave lenses. But what happens is these two are not going to be switched. That make a switch. Single arrow is coming from here and going here. Using concave lenses, we can't do it. Right? Concave lenses can make the cross and rectangular isosceles prism. Yeah, it is possible. Using prisms, I mean, this is a drawn diagram when we discuss theories about rectangular isosceles prisms, right? This is the corresponding scenario. See, it switched. So C is also correct. C is also correct. A and C. A and C. A and C. You know, A and C. For A and C, 27, answer 4. Now, if you don't know these ray diagrams, you can take down. So that's why I'm drawing these ray diagrams. Otherwise, if you can remember these ray diagrams, even without drawing the ray diagram, you can finalize the answer, right? So if you're clever enough to recall them in your head, you can finalize the answer even without drawing any ray diagram. Now, this is to show you how it happens. $28. A clear image of a remote object is focused onto a screen, right? Remote means the object is at infinity. Yeah, remote kya lagyan infinity. Remote, far, distant. Any word refers to infinity. That is focused onto a screen. Onto a screen. There are a few hints to be taken. Onto a screen means that's a real image, right? Real images are formed only due to convex lenses. So therefore, this lens using here has to be a convex lens. That is the first hint you should take. That is the first hint you should take. Right? It has to be a convex lens. Then the distance between the lens and the image is 20 centimeters. What's the hint? Which means that is a convex lens. If rays are coming from infinity to a convex lens, right, it will be converged at the focal point, which means focal length of that convex lens is 20. Right? Focal length of that convex lens is 20. Let's say f1 is 20. That is a hint you have to take. L1 L1. Now let's consider now another lens L2 is kept in contact with L1. This is L1 now, right? L2 is kept in L1 and clear image of object was obtained on the screen again. Which means again the resultant lens is again going to be a convex lens, right? That is again a convex lens. The distance between the screen and the lens combination was 25. Again, second combination convex lens, right? If this is the combination, now again it has done the same thing. And focal length of this combination, this is a combination. Focal length of the combination is 25 centimeters. Right. Now, what you can do is we can apply lens formula, combined lens formula. 1 over capital F equals 1 over F1 plus 1 over F2. And you have to apply sign convention. You have to apply this with sign convention. Right. This is a convex lens. Right. Then for a convex lens, focal length is minus. And this is also a convex lens. Make up convex lens. That is also minus, which means minus 1 over 25 equals minus 1 over 20 plus 1 over F2. Simplify this. 1 over F2 equals, this is 1 over 20 minus 1 over 25. Common denominator is 100, right? Then 5 minus 4 here, which means F2 equals 100 centimeters. F2 is 100. This is plus. Plus here, concave. Then 100 concave. 100 concave 5. For 28, answer 5. $29. Incidence of sunlight on a spherical raindrop with an angle of I is shown in the figure. Consider the following statements. X can be red and Y can be blue. Okay. See. Okay. So what here? Right. X and Y. X and Y. Okay. Then if this is X, this one is X, this is Y. Alright. Okay. Right. X can be red and Y can be blue. Right. X can be red and Y can be blue. So we know. I think in last step also from this color dispersion we had a question, right? As I can remember, we had a question. So when we compare red and blue, refractive index of red is less than refractive index of blue. N of blue. Refractive index of red is less than refractive index of blue, right? Which means deviation, no? Or we can say bending of red is less than that of blue, right? In color dispersion, red is the least bent. Red is the color with the least bending. Then X can be red. X can be red. No. X can be red because X is not the least bent. Least bent is red bend. No. X can be red. No. A is wrong. B. X and Y rays are subjected to total inner reflection for all values of Y. For all values of Y. No. Where's I now? Here. For all values of Y. No. Why? Let's say this starts from 0. Right? All values to that is including 0. Right? Including 0. If there is 0, right, nothing happens because it goes through the center. Right? When the angle is 90, no refraction. If there is no refraction, this will also be 90. No refraction. So at 0, it is contradictory. I equals 0 only when it's wrong. The deviation of X is greater than the deviation of Y. That is about total deviation. Right? If I need to check total deviation, see, total deviation is measured with the original direction and final direction. This is the original direction. And this is the final direction. This is the final direction. Right? So this deviation of X is from this original direction to here. And this is Y. Right? Y got connect and that is only up to here. So deviation of X is greater. Deviation of X is greater. Deviation of X is greater. That is correct. Only see. 29.3. Right? Deviation is total deviation. Total deviation is the angle between original direction of light ray and final direction of light ray. Original means very first light ray. Final means very last light ray. Right? Isn't that convex in 28? It's given as 25, eh? $25 centimeters. So the combination is 25 centimeters and L1 is 20 centimeters. Right? Lens type. We are getting plus 100. Plus 100. Plus focal length means concave lenses. Minus focal length means convex lenses. Right? Plus 100. Concave. Alright? So in here C was correct. Only C. 30. A person is away. Here's a sound broadcast by a loudspeaker with a uniform intensity. Now the power output of the loudspeaker was brought up to 1/10 of the earlier value. Right. The distance that must be traveled towards the loudspeaker in order to increase the new intensity level by 10 decibels. Right. Okay. Now there are two things. Right. One is the power output change is there, and again a change in distance is also there. So we can't factor both. We can't consider both at once. We have to have two equations, right? So first let's see what's the impact with this power output, right? Apply a delta beta equation. If you have a change in intensity level, directly use the delta beta equation, and we can write delta beta in terms of power. Power equation එක මේක 10 log base 10 P1 over P2, right? Then I'm going to find delta beta now. 10 log base 10. Now initially let's say power was P. Initially P. And finally P over 10. 1/10 P over 10. P cancels, right? So delta beta equals 10 log base 10, 10. Log base 10, 10 is 1. So which means delta beta equals 10 decibels. Right. Now due to power output, due to the decrease in power output, intensity level reduces by 10 decibels. That's the idea here. Intensity level reduces by 10 decibels. Right. Now, if this is the initial value, see, if this is the initial value, let's say this was the initial value, and now due to this power thing, now it is reduced by 10 decibels. Now it is reduced by 10 decibels here due to power. 1/10 of power. And the question is to increase new intensity level by 10 towards the loudspeaker in order to increase the new intensity level by 10, which means it has to be increased from here. Then power output still it need to be increased by 10. It need to be increased by 10. New is here, which means from this level, this is what you need to understand. This is what is tricky here. From this level, now we are at here with this power, 20 decibels has to be increased. From this level, 20 decibels must be increased. 20 decibels. 10 increase 20. Right? Then use delta beta equation of length. Delta beta equals 20 log base 10 R2 over R1. Change of intensity level with distance. Right? In distance equation, we have 20 log, not 10 log. Then delta beta is 20 now. 20 equals 20 log base 10 and initial distance 100. 100. I'll assume the final distance as x. Right? Then 20 to 20 cancels. Then 10 to the power 1. 10 to the power 1 equals 100 over x. Then 10 to 10 cancels. X equals 10 meters. X equals 10 meters. Which means this person should be 10 meters away from this speaker. Right? Then the travel distance is 100 minus 10. Initially he was 100 meters away. Now what this says is, now he should be 10 meters away. Then travel distance is 90 meters. Right? So therefore, travel distance is 90 meters. For 30, answer 4. That's again a tricky question. That is again a tricky question. If you didn't understand that increase properly, you might have applied 10, right? But if you applied 10 as the difference, that is wrong. The actual difference is 20. First 10 is decreased due to the power output, and then another 10 should be increased. Then from that level, it's an increase of 20 decibels. $31. The length of thermometer wire under certain tension is 80 centimeters. A knife edge is placed at the middle of the thermometer wire without affecting the tension. Due to the knife edge, the wire has been divided into two parts with lengths. Okay. Then a single wire of 80 centimeters. Now with this knife edge, it is divided. With this knife edge, it is divided. Understand what it says properly. 39.5 and 40.5. Then this part is 39.5. 10 beats, right. Okay. Now this is a fundamental frequency here. And this will be the fundamental frequency here. Right. And this part is 39.5. And this part is 40.5. Right. So let's say frequency of this part is F1. Frequency of that part is F2. Right. Let's assume that way. And beats frequency is 10 loop. The vibration frequencies of each part of the wire are. Okay. Vibration frequencies of each part of the wire are. Look at here. A good one. It's again a good question. Right. And now we have to make a decision. And before doing the calculation, you have to have an idea whether F1 is greater than F2 or F2 is greater than F1. Right. Always, when it comes to the length and frequencies, the relationship between length and frequencies, always length and frequency are two inverse things. They are inverse. This you need to know. See, frequency and length are inverse. Frequency and length are inverse. So therefore, for sure, F1 is greater than F2. Right? For sure, F1 is greater than F2. Right? Lesser the length, higher the frequency. Lesser the length, higher the frequency. That is something we prove in waves. Right? Lesser the length, higher the frequency. Having that idea in mind, now beats frequency means number of beats. Number of beats means the difference between frequencies. Resonance is the phenomenon of having equal frequencies. Right? Equal frequencies. Resonance. Beats means the difference of frequencies. Now beats 10, which means F1 minus F2 is 10. F1 minus F2 is 10. Let's say 1. Right? And now for this one, we can use V equals F lambda. Right? See, if I use lambda, this is lambda over 2. Let's say lambda 1. Lambda 1 over 2 equals 39.5. Right? And for the other one, let's say lambda 2. Lambda 2 over 2 is 40.5. Right? We know V equals root T over M. Right? If we have same tension, it says that's the same tension, and same wire, M is also same, which means V should be constant, V should be same. Then what I can argue is, as V and V are same, velocity of these two wires, velocity of both wires are same. Right? V equals F lambda. Then V is F1 lambda 1 from first wire, first side. Then F2 lambda 2 from the next side, other side. F1 lambda 1 is 2 times 39.5, and F2 lambda 2 is 40.5 times 2. 2 cancels, and F1 can be written as 10 plus F2. Okay? F1 is 10 plus F2. Then this is 10 plus F2 times 39.5 equals F2 times 40.5. See, I'm going to simplify at once. Now from this side, we will get 39.5 times F2. Here I have 40.5 times F2, which means F2, 1 and 40.5 minus 39.5, 1. And this is 395, which means F2 equals 395 Hertz. If F2 is 395, from 1, F1 is 405. Right? 405 and 395. 405 and 395. 405 and 395. 3. 3. For 31, answer 3. Take it down. That is also a good question, a tricky one. Very two. 32. A plus q point charge, point mass, is kept in the middle of the cube with length of a side 2r. The net flux through the surface of the cube is phi. What is the incorrect statement out of the following? It should be plus q point charge, not a point mass. Right? Still, the question is doable, but it should be a point charge, right? Not a point mass, point charge. Make that correction. Okay, number one. Number one, the net flux is zero when the net charge is taken out from the cube. Net flux is zero, right? So for electric flux in the first step also we had same type of an MCQ, right? Equation of electric flux is from Gauss theorem. It says phi equals q over epsilon naught, and this q is algebraic summation of charges inside Gaussian surface. Algebraic summation of charges inside Gaussian surface. Inside Gaussian surface. Right? Then what's the first one? The net flux is zero when the charge is taken out from the cube. Yes, because now the cube is acting as the Gaussian surface. If the charge is taken out, it becomes zero. One is correct. Reason is this. So one is correct. Two. The flux through the surface is phi over 8 when the charge is kept at a vertex of the cube. That is a proved scenario. So therefore I'm not going to prove it again. If that is kept at a vertex, right? When may side right? The way of doing this kind of a question is you have to make this charge surrounded by the same shape. So what you get is 4 cubes here like this, 4 cubes here like this, and another 4 cubes behind, right? Which means here one side you have 4 such surfaces. You will get 24 surfaces. Therefore, flux through one surface is q over 24. Right? Q over 24. Which means compared to initial value, that is 5 over 24. Not 5 over 8. 2 is wrong. 2 is wrong. We'll check the others as well. 2 is wrong now. 2 is wrong. 3. The net flux through the surface is twice when the magnitude of the charge is doubled. Oh, net flux through the surface is twice. Because flux is q over epsilon naught. If this is 2q, this will be doubled. 3 is correct. The net flux through the surface is not changed when minus 2q change. It should be minus 2q charge. Sorry about that. Minus 2q charge is kept in addition to the plus q charge inside the cube. Minus 2q. Then algebraic sum. Minus 2q plus q again. It's minus q again. So net flux doesn't change. Only the direction changes. Flux net flux is not changed. That is also correct. Because we are applying this phi equals q over epsilon naught. And q is, it will be plus q minus 2q over epsilon naught. That is minus q over epsilon naught. Still, the magnitude is same. Initially, it was q over epsilon naught. The net flux is less than phi when the charge is, the net flux is less than phi when to change the charge. Q is kept in the center of the sphere with the radius r instead of a cube. Less. Yes. Why? That is from this. there is another equation for phi as EA. Phi equals EA. Right? So higher the area, higher the phi. Lesser the area, lesser the phi. So if this is replaced with a sphere, sphere. If this is replaced with a sphere, the area becomes less. When area is less, phi is less. Phi is also correct. So answer is 2. For 32, answer 2. For 32, answer 2. $33. The internal resistance is 0 in all 3 volt cells in the diagram. G is a center 0 voltmeter. The plus end of it is connected to X. Okay. And minus end is touched with A, B, C, and D respectively. Then the voltmeter reading are in order. Right. A, B, C, D. Right. Now, center 0 voltmeter. Center 0 voltmeter. Center 0 voltmeter measures. Center 0 voltmeter measures the voltage difference between the positive terminal and the negative terminal. It always measures the voltage difference between the positive terminal and the negative terminal of the voltmeter. Right? Now, in first scenario, it is kept at A. It is kept at A. Right? That is kept at A. Which means, if you need to check it out, this is what we do in current electricity. Very simple question. See, let me take it down. If you understood this, that will be very simple. 100, 200, 300. 100, 200, 300. A, B, C, D. Right. And X. 3 volts. 3 volts. Center 0 voltmeter. Okay, first it is kept at A like this. First it is kept at A. Right. Now, if you need to get that value, write the potential difference from X to A. Write the potential difference from X to A. Now, Vx is at the plus side. Now, for this moment, Vx and V plus are same. Then start from here. And in batteries, we know we draw these arrows in current electricity. Right? Start from here. Vx can be V plus to the direction of arrow plus 3. And V at here. That is VA. VA is V minus. I need the difference between V plus and V minus. Right? V plus. V plus can notation. V plus is a notation symbol. Right? It's a symbol. Then V plus minus V minus minus 3. So first answer, first reading is minus 3. Very straightforward. Why? There is only one answer with minus 3. Answer 4. Second එක ගන්න හැටි මම කියලා දෙන්නම්. මේ දැන් ඕන answer එක finalize කරන්න පුළුවන්. Second එක ගන්න හැටි කියලා දෙන්නම්. Second එක ගන්න ඕන නම් current flow එක වාගත්තා නම් හරි. Right? Now second scenario is this will be kept at B. This will be kept at B like this. Right? Now I need to get the current flow. To get the current flow, apply Kirchhoff's laws for this loop. Sigma E equals sigma ER in this direction. Sigma E 3 and 3 again 6. I need I. R is 100, 200, 300 and 600. Total R 600. So I is 6 over 600. 6 over 600 kilograms 0.01 amperes. So that is actually 10 milliamperes. 10 milliamperes. Now, if you need to get the second answer, B එකටනේ ඕනේ. X වල ඉඳන් ආයි B වලට මේක ලියුවා නම් හරි. Start from X. Start from X. See? Then Vx is V plus නේ. V plus. plus 3, plus 3. And the current flows in this direction. This is how the current flows. This is how the current flows in this circuit. Current flows in this direction. Now, when we go through the resistor to the same direction of current, that is minus IR. Minus I. I can 0.01. 0.01. R is 100. And now we add B. B can V minus. Right? Very simplify. V plus 3. This is minus 1 equals V minus. Right? And V plus and V minus difference is, this difference is minus 2. Minus 2 තියෙනවා. 33 answer 4. අනිත් points එකට හොයන්න ඕන නම් I ටික හොයන්නෙත් මේ විදිහම තමයි. එකින් එක check කරලා බලන්න. No need to write all because the answers are given in such a way that if you need 1 or 2, you can conclude the final answer. Current electricity. Current electricity. $34. A circular loop of conducting wire has been connected to a circuit as shown in the diagram below. P and Q are 2 points at the ends of a diameter. Point P is permanently fixed, and the key R can be slided from P to Q. From P to Q. All right. Change in magnetic flux at center O due to current in circular loop with the distance x from P to Q is very well represented by. Okay. 34. Again, this is something you must know. This is something you must know. If currents are divided, right? Very important, very popular questions are coming from this, right? If currents are divided in a circular loop, if currents are divided in a circular loop, right? Magnetic flux density we call B. B at center. Magnetic flux density at center always becomes 0. Right? If currents are divided in a circular loop, that always happens. If a single current is divided in a circular loop, right, doesn't matter how it's going to divide, whether half, 1/3, 1/4, doesn't matter how it divides. As long as it's a circular loop, it is always 0. It is always 0. So that's a very popular scenario, and this is a must know thing. Answer is 5. From this I got it. At center that is always 0. At center that is always 0. For 34, answer 5. Right? For circular loops, we prove it in magnetic fields. That is something we prove in magnetic fields for circular loops. Right? 35. The diagram shows the shapes of 2 liquid drops, A and B. Consider following statements. Right. Glass plate, liquid A, liquid B. Right. A. The density of liquid A is greater than density of liquid B. Liquid B when known, that's missing, but you can understand it. The density of liquid A is greater than the density of liquid B. Right? There is no relationship. There is no relationship between or no link between surface tension and density. There is no relationship between surface tension and density. So therefore, we can't say, that is inconclusive. That is inconclusive. There is no link between these two. So therefore, statement A is inconclusive. We can't say inconclusive. We can't say. Right? So therefore, A is wrong. B. The surface tension of liquid A is greater than the surface tension of liquid B. That is correct. That is correct, because when surface tension is higher, always the liquid gets contracted. And when the surface tension is lesser, it gets spreads. Right? These are spreading liquid. Spreading. and this is a contracting liquid. Spreading and contracting, right? In a contracting liquid on the same surface, so we can compare. Surface tension is higher. Surface tension is higher because surface tension is, listen, surface tension is due to intermolecular forces. Surface tension is due to intermolecular forces. Intermolecular forces are intermolecular attractions. Intermolecular attractions. Higher the attraction, higher the surface tension. Now here, this is a higher attraction. So higher surface tension. B is correct. B is correct. C. The angle of contact of liquid A is greater than the angle of contact of liquid B. What is angle of contact? What is angle of contact? Angle of contact is the angle between the wall and the liquid surface. Wall and the liquid surface. Tangent. Wall and the tangent drawn to liquid surface through the liquid. Wall and the tangent drawn to liquid surface through the liquid. So this is the angle of contact here. And here tangent drawn is this, through the liquid angle is this. So you can see which angle is greater. In A, angle is greater. Right? Then B and C. 4. 35. Answer 4. Angle of contact is the angle measured between the walls of container and the tangent drawn to the liquid, through the liquid. Right? Next. Six. Okay. Before that, any questions up to here? We have discussed 35. Any questions up to here? Any questions? Anything to clarify? Anything? Or is it all clear up to this point? Now we have discussed 35 MCQs. Yeah, tell me, any questions? Or is it all clear? Clear. Clear. Right. Okay. 36. 36. An iron ball hung by a helical steel spring has been immersed in a container of oil. What is the displacement time graph for the motion when the ball is dragged down at t equals 0 and released? Displacement time. Right. So first idea is, if it is dragged down and released, it undergoes a simple harmonic motion. It undergoes a simple harmonic motion. It undergoes a simple harmonic motion. Right. Now, in a simple harmonic motion, we know, I explained about simple harmonic motion before as well. So we know displacement is starting from 0 and it's going to amplitude, coming back again at center like this. Now this is a simple harmonic motion, SHM. We will be starting simple harmonic motion next week for 2026 theory, right? Simple harmonic motion. For a simple harmonic motion, if this is the center, there are two amplitudes. There are two amplitudes with a single center for a simple harmonic motion. Something like this is a simple harmonic motion, right? So therefore, when it comes to displacement, starting from somewhere, if that is starting from center, displacement is 0. Then come into amplitude. Again come into center, 0. Then go into the opposite side, negative. Again come into amplitude, come into 0. Likewise, right? And now in this case, object is dragged and released. No, once the object is dragged, the release point is the amplitude, right? So once that release from that point, it undergoes the motion like this. So center is somewhere here, and the release point is the amplitude. Therefore, at the release point, it should be at the amplitude. At the release point, it should be at the amplitude. So therefore, 2 is wrong, 3 is wrong, 2 and 3 are wrong. And we have to have a small idea about the variation of displacement of a simple harmonic motion. That is non-linear, right? That is sinusoidal. That is sinusoidal. අර කලින් question එකකට හම්බුනේ sinusoidal variation එකක් තියෙන්නේ මොනවද කියලා අහුවේ. That is sinusoidal. So therefore, sinusoidal variations here are 1, 2 and 5, right? Sinusoidal means that's waving, the wave type, waving, right? 1, 2, 5. And from that, now here, since that is inside a liquid, it losing energy, it's losing energy over time. That is inside the liquid. So due to viscous forces of the liquid, it's losing energy over time. When the energy is lost, slowly its amplitude decreases. That is what happens in a simple harmonic motion, and we call such motions as damping oscillations. Damping oscillations. So due to energy loss, that is a damping oscillation. Damping. So therefore, what satisfies all? 5 ne? Only 5. 2 එකේ තියෙන damping එකක් නෙමෙයි. 1 එකේ තියෙන damping එකක් නෙමෙයි. 2 එක අපි we have already removed 2 නේ, because that is starting from 0. We have the tie between 1 and 5. And 1 is not a damping, right? Damping means amplitude decreases over time. So answer is 5. For 36, answer 5. For 36, answer 5. That's a damping oscillation. Damping oscillation. Damping means it's losing energy over time. It's losing energy over time. Damping. We call it damping. Right? 37. 37. In 37, there's a small typing mistake. Without that, you can't do the question. It should be corrected like this. 37, I'm referring to 37. It should be corrected like a roof of 500 kilograms has been mounted on 4 steel pillars with, let's say, a roof of 500 kilograms has been mounted on 4 steel pillars of height 8 meters. Of height 8 meters. Right, 37. 37. In 37, there's a small typo. Right? It should be corrected as a roof of 500 kilograms has been mounted on 4 steel pillars of height 8 meters. Of height 8 meters. Of height 8 meters. Right? Without having that, you can't do the question. So therefore, for 37, I'll give it as all. Right? I'll give it as all. Typo. Right? I'll do the question. Right? Now, with this correction, I can do the question. Now, without that, you can't do. So consider it as all. Right? I don't know left, you know. Right? 37, all. Okay. Cross-sectional area of pillar is 25 square centimeters. Young's modulus is given. If the weight of the roof is equally bared by pillars, the contraction of length of pillar due to roof is, right? Elasticity. In elasticity, we only have one equation for Young's modulus. Very direct application. This is a common question, right? Common type question. 37. Young's modulus F of A equals Y times E over L. Young's modulus, right? So force is 500. There are 4 pillars. Then 125 each. Then force is 1250. Right? 500 over 4. And A 25 square centimeters 10 to the power minus 4, 2 times 10 to the power 11. We need E, extension. We need extension. Contraction is the extension, right? L, 8 meters. Simplify this. This is 25 times 50. 25 times 50, right? Then this is 2 times 4, right? 4 times 5 again, here 200 comes, right? 4 times 5, 200 comes, right? 4 times 50, 200 comes, 10 to the power 4, and this side 10 to the power 11. Altogether this is 10 to the power 6. Then here 10 to the power 5 remains. So E equals 2 times 10 to the power minus 5 meters. 2 times 10 to the power minus 5 meters. Millimeters will in. So that is equivalent to 2 times 10 to the power minus 2 millimeters. 37 answer 2. 37 answer 2. For your case, I have given this as all because this data was missing. This data was missing. $38. A conducting rod has been attached to 2 helical springs and held stationary as shown in the figure. A uniform magnetic field is there perpendicular to the rod into the plane. PQ rod is dragged towards right hand side and released. Okay, dragged to right hand side and released. Let me take it down. PQ. Okay, the field is cross. Field here is cross. It is dragged to right hand side then released. Dragged to right. Dragged to right. Dragged to right and released. Which graph represents the variation in potential of Q in one oscillation relative to P? Potential in Q, we need this. VQP. Potential at Q relative to P, VQP. The magnitude of induced EMF in the coil ABC is decreasing with time at a uniform rate. Oh wait, the magnitude of induced EMF in coil ABC. That part is not in the question. The going typing mistake. Cut it off. The magnitude of the induced EMF in the coil ABC is decreasing with time at a uniform rate. Cut it off. Right? Question is over from there. Right? Okay. See. Okay. See. Now if it is dragged to this side and released, then initial motion of direction will be leftwards. Initial direction of motion is leftwards because it is dragged to here, dragged to this side and released. Then when the springs are contracted and stretched from this side, then it comes back again. So initial direction of motion is to the left, right? And now induced EMF on the rod. Induced EMF is given by Faraday's right hand rule, right? Faraday's law is. So induced EMF, direction of motion is V to the left, right? This is called right hand rule, right? From right hand rule, this is the direction of motion, and this finger, thumb direction of motion, thumb is direction of motion, and first finger is direction of magnetic field, and middle finger gives you the direction of induced EMF, right? Then direction of field is cross and motion is leftwards. See, middle finger is downwards, which means direction of EMF is to this side. Direction of EMF is this side, which means where is P and Q? P and Q, right? So if it is to this side, VQ is greater than VP. VQ is greater than VP, right? VQ is greater than VP. Since VQ is greater than VP, now we need VQP. VQP VQ minus VP. So this is a positive value. This is a positive value. This is a positive value. And again, this is a simple harmonic motion again. Right? Very much comparative with the previous one. This is simple harmonic motion again. Velocity of a simple harmonic motion is also wait. Which graph represents the variation of potential Q one oscillation with respect to P. Okay. V then let's see VPQ, right? And that changes with E equals BVL or BLV, right? BLV. This is the equation. Now, since this is a simple harmonic motion, a good question. Now you need to know about all the things to finalize the answer. You need to know about all of these things to finalize the answer, right? Magnetic fields, induced EMF, simple harmonic motion, and this is coming from current electricity. So everything is connected here. Everything is connected, right? Now, when velocity changes, E changes. Since it is a simple harmonic motion, right? Velocity is sinusoidal. Since that is a simple harmonic motion, velocity is sinusoidal. So E is also sinusoidal, right? Since E is sinusoidal, E is EMF. EMF is a voltage. EMF is a voltage, or we can say potential. EMF is a potential. Right? Now, when V is sinusoidal, E's variation is also sinusoidal. When E's variation is sinusoidal, this VQP is also sinusoidal. Right? Linear in the back. So which means 2 is strong, 3 is strong, 5 is strong. Right? And for initial direction, Q was greater than plus. Answer is 4. Answer is 4. 38, answer 4. Very good question, a tricky one. You have to know many things to finalize the answer. It's a combination of simple harmonic motion, electric fields, current electricity, magnetic fields, and magnetic induction. (39). Okay, in 39 question also there's a small typo. Correct as this. As rendered in diesel engine is shown in the figure. The most suitable expression for non-symbols delta T, delta Q, delta U, and delta W for the rapid contraction process. Rapid contraction. Rapid. For rapid contraction. Rapid here word for rapid contraction process from situation the cylinder filled with diesel oil. Rapid contraction. For rapid contraction. For rapid contraction. Right? Rapid again, rapid contraction. 39. Right. Any rapid process is this is from thermal, and this is called thermodynamics. This is from thermodynamics. Thermodynamics is also one of the easy lessons compared to other lessons in other parts in thermal. Thermodynamics is kind of easier, right? Rapid processes are adiabatic, right? Rapid processes are adiabatic, right? First idea is rapid processes are adiabatic. Adiabatic means delta Q equals 0. This is the first hint, right? And now that is a contraction, no? In a contraction, volume decreases. In a contraction, volume V decreases. When volume decreases, temperature increases. When volume decreases, temperature increases. Right? So therefore, delta T is greater than 0. Temperature increasing. And sign of delta T and delta U will be same. Delta T and delta U will be same. So delta U is also increasing. Right? And since there is a decrease of volume, delta W is P delta V. All the equations should be known. Delta W is P delta V. Now, since there is a contraction, delta V is negative. Since delta V is negative, delta W will be negative. Right? Delta T is greater than 0. Delta T positive. Greater than 0. Delta T is positive. And delta U is positive. Delta T positive, delta U positive, delta Q 0, delta W minus. Answer 1. 39, answer 1. So this is an easy part in thermal. If you don't know these equations, if you can't recall these equations, quickly go through the notes and recall these equations, because from thermodynamics, that is a definite MCQ coming. That's a definite MCQ coming, right? 1 or 2 MCQs are coming. Definite 1 is coming, right? So you can secure that 1 mark if your thermodynamics equations and thermodynamics parts are known. Very small part in thermal and very easier part. Right? And it's a doable one. It's a very much doable one. Right. 40. I didn't get 32. 32 electric flux. Electric flux. That question is solely driven from Gaussian law. Gaussian laws. Right? From Gaussian laws, we can write phi as Q of epsilon naught, where Q represents the algebraic summation of charges inside Gaussian surface. Right? For all 4 statements, 1, 3, 4, 5, I use Gauss law. And for second one, to get the flux, we have to see how many symmetric surfaces are here in that diagram, right? Symmetric surface in the sense, now if there is kept at a vertex, you have to surround it with the symmetric shapes to cover the charge entirely, right? So therefore, if we have to cover that charge, such 8 cubes should be placed. Charge now if the charge is here, right, to cover this charge, we have to keep this one here, another one here, another one here, and another one here, right? And then behind this also 1, 2, 3, 4. So altogether you will get 8 cubes. In 8 cubes, there are 24 such surfaces. What I did now, 24 surfaces. 4 into 6. 24 surfaces. Then flux through one surface is Q of 24. So flux is phi of 24. Right? That is how it is proved. 39, 40. 40 is a good question. 40 is a good question. Center of gravity, and that's a good one from center of gravity, good in the sense, a tricky one. There are uniform cubes on a toy box. A child makes a pillar using these cubes on a rough plane, which is inclined to the horizontal at an angle theta. The cubes do not slide on each other. If tan theta equals 1/8, maximum number of cubes that can be stuck without falling down. See, center of gravity. So we know an object falls if center of gravity is outside the supporter, no? Right? In center of gravity, we are proving that the condition to be satisfied to topple an object, to fall an object is its center of gravity should be outside the supporter. Then just to keep at equilibrium, it should be at the neutral equilibrium. Neutral equilibrium means that should be at the edge of the supporter, right? There are cubes, so I'll consider side length as x. I'll consider side length of the cube as x. And we don't know how many cubes are here, right? So let's consider side length as x. Now the side length is x. And when all are kept like this, not to fall, this is how the weight should be acted, because it should be at the end of the supporter. This is called a neutral equilibrium. Neutral equilibrium. And this is the final point, last point. This is the last point, very last point. We can keep this system at equilibrium, right? This is the very last point. We can keep the system at equilibrium. Then in that scenario, the weight acts here from the edge of the supporter. This is called the supporter. This is called the supporter, right? Now in that scenario, weight acts at the edge of the supporter. Weight acts at the edge of the supporter, right? So let's consider side length as x. Right? Let's consider side length of this cube as x. Now, I don't know how many cubes are here, right? We don't know. I'm just going to consider the system. Going to consider a system at once and going to find out the height to center of gravity. So let's say the height to center of gravity here as h. Let's say this as h, right? Now, if this is theta, this is 90 minus theta. Let me extend this. 90 minus theta. This is also 90 minus theta. This is theta again. Using this triangle, I can write tan theta. Tan theta will be opposite side x. Right? Opposite side opposite side is x over 2. Opposite side x over 2. Right? Center of gravity at the center. So this is at the center. So if side length is x, this is x over 2. And adjacent side is h. And tan theta is given 1 over 8. That is x over 2h. Then 2 to 8 cancels 4, which means h equals 4x. H equals 4x. What's the idea? Idea is height from this point to center of gravity of the system is 4x. Center of gravity is at the center of the cubes, right? Now I considered one cube as x. Then to have the height of center of gravity 4x, there should be 8 cubes. 8 cubes, 8x wala center ekana me avilla. Center of gravity is at the center. So there should be 8 cubes. 4x means 8 cubes. Right? 4x is the height to the center of gravity. Center of gravity is at the center of the system. Then 4x and 4x. Make a 4x now. If this is 4x, right? If this is 4x, this should also be 4x now. Then 8 cubes altogether. 8 cubes. 40, answer 4. That's a tricky question. Center of gravity. A tricky one from center of gravity. Is it clear? 41. The hydrometer floats in a liquid of density 750. As 1/5 of the total volume is above the equator. You know hydrometer, no? So when a hydrometer floats, this is called the hydrometer. When the hydrometer floats in a liquid, right? So it follows law of flotation. It follows law of flotation, right? Mg and U. When hydrometer flows, U equals Mg. It follows law of flotation. Same hydrometer, no? If there is same hydrometer, same mg. If there is same hydrometer, same mg. If there is same hydrometer, same mg. Same mg means same u. Then in both scenarios, u should be same. Right? We know u equals v rho g. Then for initial side, let's say v1 rho 1 g. And this is v2 rho 2 g. G to g cancels. v1. When a hydrometer floats in a liquid of density 750 has 1/5 of the total volume is above the liquid. 1/5 is above the liquid, which means 1/4 is, sorry, 5/4. 5/4 is below the liquid. 1/4 is above, 5/4 is below. Again, this much of a volume is inside the liquid. And density of the liquid is 750. The density of liquid in which the hydrometer floats as 2/5 of the total volume is above. 2/5 above means 3/5 is below. Then 3/5 is below. I need rho. Rho 2 kilo. V to V cancels. 5 to 5 cancels. 3 times 250, which means rho 2 equals 1000. 1000. 41 answer 3. 41 answer 3. $42. If BA, BB, and BC are magnetic flux densities, again magnetic fields, right? Magnetic flux densities due to currents in the conductors, the correct relationship among those. Okay. Equation for magnetic flux density of a curved wire, of a circular wire is this. Equation B equals mu naught over 4 phi I theta over R. This is the basic equation, right? I theta over R, right? Now for A, 2R and R, now you have to check this one by one. It is like this. And the current flows like this. Let's say I, current flow is I, then the current flows like this, right? And if any part is going through the point that we consider, BA, from such parts, there is no contribution for electric flux density. From such parts, to check the direction, you have to use right hand rule. Direction of this magnetic flux density is, look at here, direction is cross, right? And from this current also, direction is cross. Put these fingers, put all these 4 fingers to the direction of current flow, and thumb gives you the direction of magnetic flux. This is cross, this is also cross, which means these two are going to be added. So BA is mu naught of 4 phi is common. I'm going to take these things out. Mu naught of 4 phi is common. And other than that, I is also common. Theta is also common. Theta is subtended angle, this one. That is phi. Right? Only R is different. Then here, what comes is 2R plus R. Like this. Right? So this part is anyway common. That is constant. I'm going to compare only this part. 1 over 2R plus 1 over R 2R. And this is 3. Right? 2. Yeah. This is the value. And for the second scenario, I'm writing these values for your understanding. Otherwise, now if your understanding is proper and if your understanding is thorough enough, you can just argue and compare these values as well, right? 2 with 2R. So here it is like this. 2 rings with 2R and 2R. right? And on this string, current flows like this. So direction of magnetic flux is on this one, on vertical one, direction of magnetic flux is this. And on the horizontal one, it flows like this. Direction is upwards. So there are two perpendicular directions, B and B, right? So 1B is written as, 1B can be written as mu naught over 4 phi. This same thing comes, mu naught over 4 phi. Then I theta. Now in this case, theta is not phi, total angle 2 phi, right? And R 1 over 2R. 2 to 2 cancels. See, B is mu naught over 4 phi, I phi over R. But the resultant is this. Resultant is this. Resultant will be root 2B, right? Now, I have discussed these things. Before. If you have two identical vectors with perpendicular directions, always the resultant comes as root 2 times one vector, right? It is coming as root 2 times one vector. So you have to know them because we are doing an MCQ, no? Right? Otherwise, make a equation. Now, from this, I am getting this, right? So that is root 2 times one vector. Then root 2 times one vector again B mu naught over 4 phi I phi. Mu naught over 4 phi I phi කියන එක මම කලින් K කියලා assume කරානේ, right? Over R. This part was K, previous case. Now this is root 2 K over R, right? 3 over 2 ne 3 over 2 කියන්නේ 1.5. You can compare. This is 1.5 K over R. මෙතන root 2 K over R, root 2 K කියලා කියන්නේ root 2 1.414. Root 2 is 1.41. This is 1.41 K over R, right? For the third scenario, right. This is how the current flows. Now from these two parts, again, no magnetic field is coming. B equals, now mu naught over 4 phi. Check directions first. See, mu naught over 4 phi. Check directions. Now from this outer loop, it is cross. From the inner loop, there is dot. Always lesser the distance, lesser the radius, higher the field. When radius increases, field decreases. When radius decreases, field increases. So therefore, the net flux here is dot. And that is angles are same and currents are same. I phi is common. 1 over R minus 1 over 2R. Right? Opposite directions. Hariයට subtract කරලා දාන්න ඕනේ. Opposite directions. Here the direction is dot. From the smaller part, there is dot. From the larger part here, there is cross. Then from that dot value, subtract the cross value. They are vectors. Right? Dot and cross are two opposite directions. Right? Okay. Then simple like this. B equals, I consider this as K. This is K now. And here 2R. 2 minus 1 කියන්නේ 1. So this is 1 over 2 කියන්නේ 0.5 K over R. Now you can compare. This was BA and this was BB and this is BC. Right? So that is in the same order. BA is the largest, then BB and then BC. BA 2 ne 2 42 answer 2. Electric fields. 43 electric fields. Take this down quickly. Take it down if you didn't do. Write down. Right. 43. 43. A and B spherical conductors with radii R1 and R2 respectively are kept apart by a distance which is extremely greater than their radii and connected by a long conducting wire. If the charges on A and B are at the equilibrium are Q1 and Q2 respectively, the ratios between potential and field intensities are right. If two conductors are connected, their potential becomes equal. Right? If two conductors are connected together, their potential becomes equal. Right? Then Q1 R1, Q2 R2. So if they are connected together, their potential becomes equal. So therefore, first one VA to VB, it should be 1. Right? Potentials are equal. Potentials are equal if connected. Potentials are equal if connected. Right? So therefore, that is very straightforward. That is 1. Right? And we need E. Since potentials are equal, now from this we can get a relationship between Q and R. See? Then V equals V. V of electric field is, this is the equation. V of electric field is written as 1 over 4 pi epsilon naught. Electric fields, this is the V of at the surface of a sphere. Q over R. Right? This is the basic equation. This is a constant. So therefore, I will consider this as K. Right? Then that is K Q1 over R1. And this is K Q2 over R2. K to K cancels. See? Q1 over R1 equals Q2 over R2. Having this in hand, now we can write field intensities. Electric field intensity at the surface is written as, this is the equation, electric field intensity is written as 1 over 4 pi epsilon naught Q over R squared. Q over R squared. Right? Now, we can write EA and EB. We can write EA and EB. For EA, K times, I will be considering this as K, K Q1 over R1 squared. Similarly, E2 EB can be written as K Q2 over R2 squared. We need EA over EB. Divide these two. EA over EB equals K to K cancels Q1 over R1 squared. Right? R2 squared over Q2. Okay. Now from here, we can substitute Q1 over R1. I'm going to create Q1 over R1 here. See? Q1 over R1. And here, now what's remaining is R2 squared over Q2, 1 over R1. Correct? Q1 over R1 can be substituted as Q2 over R2. This is Q2 over R2. Q2 over R2 times, this is R2 squared over Q2 times 1 over R1. Q2 to Q2 cancels, R2 to 1 R2 cancels. So final answer remains here is R2 over R1. Then 1 and R2 over R1, answer 2. 43, answer 2. Right? Again, Tricky question, a good question. Forty-four. 44. If the potential difference of the ends of the cell B is 0, R is equal to, right? See, ER1 and this is ER2 capital R, right? So this is how the current flows in this circuit. Current comes out from the positive terminal of the battery. This is how the current flows. And one data, special important data is given. Potential difference of the end of cell B is 0, right? Equation of a cell is V equals E minus IR. V equals E minus IR. Now V is 0, which means E minus, let's say current is I for cell B, R2. This is internal resistance, internal resistance of the cell. Okay, which means IR2 equals E. I can subject I here, I can find I here. I is E over R2, right? So having that in hand, I'm going to use Kirchhoff laws for this loop. Having that in hand, use Kirchhoff laws in this direction for the loop. Sigma E equals sigma E. Sigma E equals sigma ER. Kirchhoff laws. Sigma equals sigma ER. Sigma E again, E plus E, 2E. 2E. I is simple I. R, total resistance, R1 plus R2 plus capital R. R1 plus R2 plus capital R. Right? And 2E equals simple I can E over R2. E over R2. R1 plus R2 plus capital R. E to E cancels. 2R2 equals R1 plus R2 plus capital R. Subject R from here. Subject R. R will be 2R2 minus R2 ke liye R2 R2 minus R1. Answer to 44. Answer to. $45. 45. When the potential difference between AB is 100 volts, power dissipation of 5 ohm resistor. Right. So first I'm going to determine the current. Again, use V equals IR for the system. Use V equals IR for the system. V is 100. I need I. And R is 2, 3, 5, 10, 20. Right. So I equals 5 amperes. Right. Power dissipation of 5 ohm resistor. Equation of power dissipation is, right, very straightforward. Equation of power dissipation is P equals VI, or we can write P equals VI or I squared R or V squared dou R. Now current is known, so I'll be going with this. P equals I squared R. I squared के लिए 5 squared, R के लिए 5. 25 into 5 125. 125 watts. 4 for 45. Answer 4. Right. Okay. Okay. 5 questions are remaining. 5 questions are remaining. I'll give you the answers for these 5 questions. Right. Now it's 10:15 now. I'll give you the answers for these 5 questions. Mark these answers for 46. It should be increasing number of turns, correct? Increasing strength of magnetic force, yes. Winding for class. ABC. right? 46 ABC. Again, 46 4. For 46, answer 4. For 46, answer 4. 47 5. 47 5. 48 3 and 12. 3. 49 2. 54. These are the other answers. Right. Any questions from the parts, from the questions we discussed today? Any other questions to be clarified? Any other doubts to be clarified from the parts we discussed? Huh? Now you can check your final mark, right? You can check your final mark out of 50 and keep it checked, because now we'll be writing part 2 of this paper this week. You will be writing part 2 of this paper this week. Then as usual, as the last week, you will be getting that paper on Thursday night, right? You will be getting the paper on Thursday night, and during Thursday night or Friday or Saturday before the discussion, you can write it as a timed paper of 3 hours and come to the discussion, right? And then we can check the final mark for the paper upon the completion, after the completion of the paper, right? So this week we will be writing a second paper, an essay paper, and that will be the essay of this one, no? Part 2 of this one, right? Okay, now we have discussed 45 MCQs, right? 45 MCQs. 45 MCQs. Any questions from the discussion? Any questions, or is it clear enough? Yeah, students, is it clear enough, or are you fed up with the discussion of 45 questions? You're hungry because 10, 15, 10, 20. Okay, clear? All right then. All right. So listen. So as I told you, this week you will be writing an essay paper, and that will be the part 2 of this one. So get ready to write an essay paper and refer structured essays and get ready, right? So in last paper also we discussed for structured essays and few essays. So this week also you will be getting a full syllabus paper, full paper, right? So get ready and prepare yourself during these days. And once the paper is put, you can write it to your best, be honest to yourself, and write it with your best effort, by your fullest effort, and come to the discussion on Saturday, right? Okay, since there are no questions, I'm going to wind up. So reminding again, now you are just 12 weeks ahead of the exam, so don't waste even a minute of the time. Always work hard by your own, and now reduce your sleep times, and try to allocate around 15 times, 15 hours. Try to allocate around 15 hours a day these days for your works, 15, 16, likewise. And during the rest 8 hours, you can have a wash, have a nap, and your meals, rest times, and everything, right? So if you have classes on the particular day, then those times will be different. But if there's a day that you don't have any classes, so try to utilize at least 15, 16 hours a day, right? So this is a very small time remaining. and what you do during this time will reflect your final result, right? Definitely that is how it will be, right? So if you need to get a good grade, you need to put more effort, right? Your effort and your grade, your result you are getting will be directly proportional, right? So what you put there, what you put to the subject will be given back to you by the subject, right? That is how it works. What we are giving to the subject will be given in return to us from the subject, right? That is how that happens for anything, right? Even if you do anything, right? And everything, for anything and everything, what you give will be what you get. Simple as that, right? That's a theory, that's a theorem, right? That is valid for anything, not just for A levels, for anything. Okay, so study hard and work hard, and have a dedication that you are going to score than the previous paper in the coming paper. So likewise, monitor your marks, record your marks for these papers, and you should be able to see the inclining trend, right? So from paper 1 onwards, monitor your marks. I told you, maintain a table for past papers and my model papers as well. Maintain a table as a paper 1, 2, 3, 4, paper number, and part 1, part 2, and total. Likewise. So have a record and monitor your marks, then you will see the inclining trend. Now always with the learnings that you are learning from the discussions right now, with the discussion of 4 to 5 questions, you might have learned many things that you didn't know, right? So take these learnings to your head, take that to your brain, store that in your brain, and keep it with you and carry it forward to the next paper. So likewise, you have to keep doing it until you face the A-level exam paper, right? So that's the ultimate goal and ultimate target. All right, then yeah, without further delay, I'll be finishing the class here, right? Stopping the class here. All right, then see you all in the next class, and get ready to write the next paper, essay paper, on Thursday, and we'll be meeting with the discussion on Saturday as usual. All right, good night and goodbye. Right, see you in the next class.